Right, this is the first of 5 videos that I'm planning to make looking at graph traversal for A-level computer science. So starting here, I've got a maze. I start the maze at the bottom, and my aim is to find the way to the top. And generally speaking, my strategy for getting through this maze is going to be just follow the right-hand wall. So I'm going to go up here. We'll call this 1, starting point. Follow this round, and then we've got a junction here at 2. Go around, follow the right-hand wall, and we hit a dead end at 3. So go back to 2, go the other way, follow it round, all the way around here until we get to junction 4. Follow the right-hand wall till we get to junction 5. If I follow the right-hand wall, I'll hit a dead end number 6. So go back to 5, follow this round to junction 7. Turn right, round to junction 8. I've got a dead end turning right at 9. Or go back the other way, dead end at 10. Let's go all the way back to here. There's another junction here at 11. And actually, there's my exit. Okay, so that's my route finding my way out of the maze. It would look something like this to follow it all the way around. And it's not the most efficient route because I end up taking a couple of little detours like this one and then some bigger detours like this one, which is not ideal, but it does get me out of the maze. And that's kind of a semi-realistic way you might follow a maze. Didn't really know where you're going. As a computational problem, that's quite tricky to try and write an algorithm to solve. So what we can do is we can represent this as a graph. So if we start at node 1, every junction or dead end is another node. So 1 goes to 2, 2 then goes to 3, or if we don't go to 3, 2 can join at 4. From 4, we can go to 5, and from there we can either go to the dead end at 6, or up to the top at 7. From 7, we can follow a dead end, well, sorry, go down to junction 8, where there are dead ends at 9 and 10. Or from 7, we can go to junction 11, which has the exit, which I'll call junction 12. And there are other bits in there as well. There's a whole series of dead ends here. There's a whole series of junctions and dead ends this way, which I haven't found yet. But they would be in there if I drew the whole graph. The point is, hopefully you can see that I can represent this maze as a graph. And once I've got the graph, I can start to apply some standard algorithms to try and get through it. And there are 3 standard algorithms that you need to know for A-level. They are the breadth first search, the depth first search, and I don't have a slide for this yet, Dijkstra's algorithm, which will be the last video that I make. So before we go through the algorithms in real detail, I just in this video want to do a quick introduction to some of the basic principles. So breadth first search, if I want to start at this node here, and this is node 11, and I want to get to node 5, now for this purpose, I'm going to ignore the weights on this graph, and ignore the edges, the weights on the edges. So I'm just going to count the hops. So what is the shortest number of hops, the least number of hops I can use to get from junction 11, node 11, to node 5? So pause the video and just by inspection, try and work out what do you think is the shortest possible route, and then we'll come back. So pause the video if you haven't already, pause it now. Right, so by now, hopefully you've got some kind of answer about what you think the shortest route is from node 11 to node 5, discounting, ignoring the weight of the edges, just counting hops. Well, what we do with the breadth first search is we look broadly, we look wide. So if I start at node 11, I'm going to call that order 0. This is my starting point. Everything attached to that is 1 step away. So node 12 is 1 step away. Everything connected to that is then 2 steps away. So node 1 is 2 steps away, node 14, node 13. They're all 2 steps away. Everything connected to those is 3 steps away. So 3, 3, 3, 3, 3, and 3. We go around again. Everything connected to those is 4 steps away. So 4, 4, 4, 4. 4, and 4. I think I've got all of them. And then everything 5 steps away is this one, this one, this one, and that's it. So this one here would be 6 steps away. And so the shortest number of hops to get to node number 5 is 4 hops. And the best way to do that is to go 11 to 12 to 1 to 0 to 4 to 5. And that's your 1, 2, 3, 4, 5 hops. And we can prove that there's no quicker way to do that. There's no shorter way to do that. Because all of the 1s are done in one step, all of the 2s are done in the next step, all the 3s are done in the next step, and so on. And so the breadth first search is a really, really kind of quite long-winded way, really, because you've got to traverse a lot of edges to try and find everything that's 1 step away, 2 steps away, 3 steps away. But you have this kind of spreading out pattern. If I change the colours on this pen and use the highlighter just to demonstrate, so this is 1 step away, change the colour. These are all 2 steps away, but I'm doing quite a lot of work, not that one, doing quite a lot of work to go back to every node and then look at all of the adjacent nodes. So it's a fair amount of effort, but you can see we're gradually spreading further and further away from the original node, looking at all the adjacent points. So I'll do 5 and then stop there. There we go. But you can see as the colours progress, they get steadily further away from the centre. And that's how the breadth first search works. It's kind of spreading across this network. And that's fine. It's a very useful algorithm. That's why it's one of the standards. There is an alternative, though, and that alternative is the depth first search. So we're going to attempt to do the same thing here. We're going to start, let's change this pen. There we go. We're going to start at node 11, and we want to reach node 5. But this time, we're going to just head off in one direction until we get stuck. So I'm going to head off, and I'll stick to the rule, always go right. So I'm going to go to node 12, and from 12, in fact, I'm always going to go to the biggest number. That's what I'm going to do. I'm always going to go to the biggest number. So 11 to 12, what's adjacent? 1, 14, 13. Go to the biggest number, 14. From there, where's the biggest number I can go to? It's 19. From there, where's the biggest number? It's 20. From there, I can't go to a number bigger than 20, but the biggest number I can see is 13. From there, I'm not going to go to any nodes I've already been to. That's pointless. So the biggest node I can see is 10. But now I'm stuck at a dead end. So I'm going to backtrack back to 13. Can't go anywhere else. Backtrack back to 20. Now I can go to 9. And from there, I can only go to 8. From there, I can go to 7. Biggest node from there is 18. Biggest node I can go to now is 17. Biggest node from there is 16. Biggest node from there is 15. Biggest node from there is 3. Biggest node from there is 4. And the biggest node from there is 5. So my route went 11 to 12 to 14 to 19 to 20 to this kind of dead end. It was 13 and then 10 and I'm stuck. And then back. From there to 9 to 8 to 7 to 18 to 17 to 16 to 15 to 3 to 4 to 5. So that was definitely not the shortest route. Okay. And if I was plonked in this maze again tomorrow and had to find my way out, going 11, 12, 14, 19, 20, don't fall for it, 9, 8, 7, 18, 17, 16, 15, 3, 4, 5, would still get me out of this maze, but I definitely haven't found the shortest route. So if I need to do this lots and lots and lots of times, there's lots and lots and lots of steps, it's not very efficient. It's going to take me a long time. If I go back, this breadth first search, I've gone to lots of nodes again. So I've gone to 1 to 12, and I've gone to 1 and 14 and 13, and I've gone to 0 and 2 and 15 and 19 and 20 and 10, and then I've gone to 3 and 4 and 16 and 18 and 8 and 9. Then I've got to 5 and found my way out. Next time, I know the shortest route is 11 to 12 to 1 to 0 to 4 to 5. 11 to 12 to 1 to 0 4 to 5. And so next time I can find my way out of this maze much more quickly, but I did have to cover the whole maze, check, or nearly the whole maze, not quite the whole maze. I had to check a very significant portion of the maze to find my way out. And that's the main difference between these two approaches. Breadth first search, you spread out, checking every node, one at a time, kind of spreading out one step away. So everything one step away, everything 2 steps away, everything 3 steps away. That takes quite a lot of time, but once you've finished, you typically have a very efficient route to get out. Time-consuming algorithm once, but really useful if you need to repeat that route in the future. The depth first search, on the other hand, can be, now I deliberately chose a very poor algorithm to go for the biggest number every time, but the depth first search can be a much quicker algorithm to find a route out, but it's not very efficient if you need to check it again and again and again. So a quick look actually. So to find my way out from 11, I checked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 nodes. I had to check to find my way out. And then my route out next time will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it'll be 14 steps to get out next time. The breadth first search, I checked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 nodes. Let's check these two. Well, I'll say yes. Helps emphasize the point. So I checked 19 nodes to find my way out. And I now know that 1, 2, 3, 4, 5 steps is my route out next time. So breadth first search took me more steps, took me more nodes to interrogate, an extra 3 nodes, but it's nearly 3 times as quick. Now, those numbers are very arbitrary. It depends very much on the graph, depends on the algorithm, depends on how you decide which route to follow. But the point is, breadth first search, this spreading out almost like a virus, takes a lot of time to do once, but once it's done, you get really, really good answers. Depth first search can be quicker to find your way through once, but if you need to find your way through many times, it's not going to be as efficient. Okay, so that's the idea of the breadth first and depth first. Next 2 videos, we'll look at the actual coded algorithms, how we can trace them, and see how these work in practice.